Okay, let's talk about something wild. Imagine a mountain range, way bigger than the European Alps, but completely hidden from view, right here on our own planet. Today, we're heading to one of the most remote, most extreme places you can think of to uncover the mystery of the Gamburtsevs, or as they're sometimes called, the Ghost Mountains.
And that's the big question, right? I mean, how can a mountain range that massive, we're talking peaks soaring over 3,000 meters, stretching for 1,200 kilometers, be totally invisible? The answer? Well, it's simple, but at the same time, it's pretty mind-boggling.
Yep, they're buried. This whole epic landscape is just locked away under more than 2 miles of solid ice, smack in the middle of East Antarctica. So what you're looking at here is a map of one of the last truly unexplored places left on Earth.
All right, so let's really dig into this geological mystery.
I mean, just think about that for a second. An entire mountain range. It was first picked up, believe it or not, back in the 1950s by a Soviet seismic team, but its very existence was a huge puzzle. See, mountains this big usually form when continents smash into each other. But the Gamburtsevs, they're sitting right in the middle of a craton, which is just a really ancient, stable part of the continent. Geologically speaking, they just shouldn't be there. It made absolutely no sense.
So for 50 years, this mystery just sat there. And to finally crack it, it was going to take one of the most ambitious scientific missions ever attempted in the polar regions.
The mission was called the Ag Gap Project. And look, this wasn't just one country going it alone. This was a massive international effort. You had scientists, engineers, pilots from the UK, the US, Germany, Japan, Australia, and China, all teaming up to finally pull back that icy curtain and see what was hiding underneath.
And they had 3 really big questions they were trying to answer. First, the basic origin story. How in the world do these mountains even form? Second, what's happening at that mysterious point where the ice sheet actually touches the rock? And third, and this is a big one, could this region, right near Dome A, which is the highest point on the ice sheet, hold the oldest ice on Earth? We're talking a perfect record of our planet's climate history, which is absolutely crucial for understanding our future.
Now, to get those answers, the team couldn't just start drilling holes everywhere. That's impossible. No, they needed a way to see through all that ice. They basically needed to give an entire continent an X-ray.
And this is where the technology gets super cool. I mean, think about it. How do you map a mountain range you literally can't see? You can't use your eyes, so you've got to use physics. So what they did was pack a whole bunch of high-tech gear onto these specially modified airplanes. They had ice-penetrating radar, which works kind of like sonar, bouncing signals down to map the rock and basically draw a picture of the mountains. They had a magnetometer to read the magnetic signatures in the rock, which tells you what it's made of. And they had a gravimeter, which is super sensitive. It measures tiny changes in gravity that can reveal things like deep geological structures and, most importantly, hidden pockets of liquid water.
Okay, so after flying more than 120,000 kilometers of survey lines, in one of the most brutal environments on the planet, by the way, the data started flooding in. And what they found was something nobody expected. You see, the biggest shock wasn't just the incredible shape of the mountains. It was water. Liquid water. And I know that sounds simple, but this one discovery would completely change how we think about the way ice sheets work.
And the sheer scale of this was just staggering. The team didn't find, a little puddle here and there. They found a massive, interconnected plumbing system down there. We now know of over 200 of these subglacial lakes across Antarctica, and a whole lot of them were mapped for the very first time by this one mission.
And this led to a totally game-changing idea. See, we always assumed that ice sheets grew from the top down, right? Snow falls, gets compressed over thousands of years, and that's that. But the AGAP data showed that water at the very bottom was actually refreezing onto the base of the ice sheet. It was growing from below, a process that's actively changing and reshaping the ice in ways we had never even considered.
And this is such a great example of how all those different instruments work together. So the radar mapped the actual shape of the mountains on the bedrock. At the same time, the graviter was measuring the gravity signal. And when they put the 2 sets of data together, they mirrored each other almost perfectly. It makes sense, right? More mountain mass means a stronger pull of gravity. This gave them a fingerprint that confirmed their radar map was dead on, giving them huge confidence in this picture of an unseen world.
Okay, so we found the mountains, we found a hidden world of water. Super cool. But why does any of this matter? Why should we care about a buried mountain range in the middle of nowhere?
Well, for starters, the data finally solved that big origin story. Turns out about 80% of the mountain's height came from big tectonic forces, things like ancient continents rifting apart. But the other 20%? That came from something called isostatic rebound. Think of it like this. Way back when, rivers and glaciers carved out these super deep valleys. That removed a ton of weight, and the crust underneath, now lighter, literally bounced back up, pushing the peaks even higher.
This also shows us just how important these mountains were for our planet's climate history. If you go back more than 34 million years, Antarctica wasn't an ice world. It was temperate, with rivers carving up the landscape. But as the whole planet started to cool down, these high peaks became a starting point, what scientists call a nucleation point, for the entire East Antarctic ice sheet to be born. The ice started forming there, and then it grew and grew until it completely buried the very mountains that gave it life, preserving them perfectly, like a giant time capsule.
And that brings us to the final and maybe the most critical question. We now know these ghost mountains were the trigger for the entire ice sheet, and we know there's a dynamic water system flowing all around them. So if this hidden world was the key to starting the ice sheet all those millions of years ago, could understanding its inner workings, the water, the geology, the heat, also be the key to figuring out its future in our warming world?